Greetings, Code fans. It is I, the Code Whisperer. Today, in honor of Codevember, we will be participating in Codevember. Now, it is November the 5th, which means today's Codevember for 2017 is Sword. So we are going to make a code pen that is all swordy and stuff. Now, the sword I've chosen to do is Guts Greatsword from Berserk, also known as the Dragon Slayer. So here's the best picture that I could find of the Dragon Slayer. As you can see, it's definitely not a very ornate sword. It's just this big, I don't even know what you'd call it. It's like a big wedge-shaped hunk going on there. And then a little bit of ornamentation at the hilt and a very, very simple cylindrical kind of handle. So we're going to try and make this in 3D using Three.js because we learned a bunch of Three.js from last time. So let us open up a code pen. I'm going to take this Berserk art and put it in my other window so I can look at it without it bothering me. If you want to see it while you're doing the code pen, just open it on up in your own thing. And let's get started on this pen. So the first thing we're 1,000,000% going to want to do is get Three.js working so we're able to kind of start programming stuff with Three.js because we're definitely going to want to start on this sword quickly if we want to get it done by the end of this video. So let us add Three.js. And then, since Three.js is so complicated, I'm actually going to look at my code from yesterday, which is the 3D Triforce. So that's got a bunch of code in it that works. So we are just going to copy as much of it as we need to get started. So basically we need a scene, a camera, and a renderer. So let's just start with those. Let's just copy the scene, camera, and renderer from our previous code pen. So if you don't understand what the scene, the camera, and the renderer do, then you should watch the previous video on 3D Triforce, because the only way we're going to get this done is if we leverage everything we know from before. So we'll define a material, and for now, a shiny mesh fong will be fine. We'll just start with the material for our base sword. We'll just call that base sword material, and it will be a mesh fong that is gray. Let's make it less reflective for whatever reason. And we'll define a size and set the size of the renderer. Don't need you any more Codevember. We're going to need a spotlight as well, so let's just add these whole 5 lines of code that create a spotlight, set its position, make it cast a shadow, set its intensity, and add it to the scene. Let's clean that up. It's looking pretty good. We don't need a lot of this script for now. So we'll make a geometry, but we'll just make this a box geometry to get started. Because as I said, we're just trying to get this to kick off the ground. It new 3 box geometry. And we'll just give it sides of 1, 2, and 1. See what I did there? Move this to the bottom. And we'll define a cube. We'll just call this sword main and make a mesh out of the geometry and the material. And then we'll add the sword main to the scene. We'll change the camera's position and update the DOM with the renderer. Are we seeing anything here? Do we have an error? Material is not defined, right? Because we want it to be base sword material. That's looking good. Is that the only place material appears? Yes, we are all good for that. So that just means we need to call renderer.render. And we should see our cube. Is that a cube? Hard to tell. How do we rotate this bad boy? We'll just say, we'll make an, heck, let's animate it. Let's copy this animation code here. And we'll just call animate here at the bottom, request animation frame, and we'll just say sword main.rotation.y. Great. So here it's rotating. We can see this is definitely a sword, and heck, this pretty much looks like Guts' Greatsword to me. Let's just finish it off now and call it a day. I'm gonna get some breakfast. No, I'm just kidding. This isn't really much of Guts' Greatsword at all. We got a lot more work to do. So let's stop this distracting animation, or let's just set the Y permanently equal to 0.4. So we just have this cool kind of angle of it. We can see what we're working with. So. Let's look at this sword again. So it's this big kind of thing. The center thing could be a prism. It could be made of prisms, or it could just be one big mesh. I don't know if we could put a different material on the side of the mesh. So to get this kind of gray thing, it might make sense to construct kind of two. So I guess let's start this thing. This thing is basically a rectangular prism that kind of goes, it doesn't go to a point, it stays flat. And yeah, it's just a pentagon, a really stretchy pentagon. So let's start with this one. So what we want is, we don't want a box geometry anymore. We want just a regular geometry. And we can tell that geometry is going to have 10 points, 5 for the front of the sword and 5 for the back of the sword. So let's look at our 3D Triforce code to get this faces right. So yeah, we need to find some vertices. So we'll make the first vertice at 0, 0, and 1. So in the bottom left, or the top left corner, a little bit close to the camera. And no, I guess we'll start at the tip. So we'll make it 0, 5, and 1. Then we'll add another vertice that's a bit lower and to the left. 1, 4, and 1. And now at that same width, go all the way to the bottom. 1, 0, and 1. And now the other side of that, -1, 0, and 1. And finally, all the way back up. 1, -1, 4, and 1. Now, if we draw a face between these, we should see a nice tall pentagon. So we'll make a new face, say geometry, dot faces, dot push. How are we going to do that? New 3.face 5? Okay, so it doesn't really look like it's going to let us draw a 5-sided face. We're probably going to have to make it out of 3 triangles, which is really annoying. Let's see, Three.js 5-sided face. Five-sided plane. Three.js pentagon. Anything? Oh, crazy. Cylinder geometry. Will that work for us? Is it a prism? No, it's not really a prism. Where is it? Yeah, it's like a five-sided prism. Heck, let's see if we can get this cylinder geometry to work, because that might save us some time. Rather than making like a million faces. So what happens if we just copy this code in and call it geometry? And n doesn't work. There is no n. 1, 5. Rotate. Let's make it rotate again so we can see what the heck is happening. It's way too big, so it doesn't fit in our viewport. Something's happening. It's doing some trippy stuff. Radius at top, radius at bottom, height, segments around radius, segments along height. Crazy. And what's this camera distance? Can we make the camera farther? Yeah, cool. So it's basically a five-sided cylinder. But will it work for the sword? No, I guess not. I guess we can't really define the granular sizes things that we need to really make this work. It is a five-sided prism though. Man, this would have been really handy in my Triforce tutorial, because this would have made a perfect Triforce piece. But as a base for the sword, it's definitely lacking. It's just not going to quite do the job. So let's just erase this cylinder geometry and go back to our plain old flat geometry. And I guess we'll just start pushing faces together. So we've got to make 3 of them. Let's start with the tippy triangle. So that should be a face between 0, 1, and 4. Getting an error. Are we getting an error? That's a weird error. It says 3 is not defined. Let's just refresh. Right, it's not 3, it's 3. 3. 3.face is not a constructor. 3.face is not a function. Face 3, of course. New 3.face3. And cool, there's the tip of our sword. It's basically the right shape as Guts' Greatsword here. Can I like make this tiny and put this in the corner? No, it's not going to want to do that. Well, rest assured, it looks right. So that's looking good. Let's cool off the rotation here. So that's the tip, and now we have to make the body, which is basically connecting a bunch of the other vertices. So we'll make one more. Copy that. So we wanted to go from the top left corner, 0, to the bottom right corner. No, scratch that. From the top left corner, 4, to the top right corner, 1, to the bottom right corner, 2. Sweet. And we need one more from the top right corner to, no, the top left corner to the top right corner to the bottom, no. From the top right corner, or is that the left corner? It's hard to say because it spins around. Let's just try it. Definitely want both the bottom corners. So those are 2 and 3. Yeah, 2 and 3. So let's say 2, 3, 1. Not exactly. 2, 3, 0. As anticipated, 2, 3, and 4. Bingo! So here we have a cool black swordy looking face. Let's define a const height so we can give it the height we want. Equals 10. Height plus 1. Height. Height. Nice. And we'll just make the camera go even farther so we can just see what's going on. 20. Cool. So there's the front face of our sword. It looks pretty darn cool. So now we got to make the area around that sword. Why is this material so dark? What if we change the color of the sword? Is there something wrong with our spotlight? Or is it just because the shape is so flat, it can't reflect light? Our spotlight is definitely added to our scene. Are we doing anything with our spotlight in this code that we're not in the other? No, it's definitely just this one block of code that makes the spotlight. But it could be that the position is too far out. Right, no, we know the light is working because our first cube did. It just must not reflect light off this because it's just flat. Should we thicken it up? That's a lot of extra code right now. We could just get away by making 2 flat halves. Let's see, Three.js, different material for faces. Okay, cool. So you can assign different materials to the faces. So we can just make this all as one giant thing and then worry about the faces later. So now what we want to do is create a second set of vertices all around the sword, but farther out and pushed back exactly 1. So could we do this with more constants? We'll just call this thickness and change all these variables to thickness. That's good, I guess. Sure looks good to me. And then we also have our width, so let's just define it. Const width equals 1. Just make that width, width, negative width, negative width. Cool. So now we'll copy these so we make some more vertices on the back. And instead of being at thickness, it'll be at 0 because those are like in the middle point of the sword. And it's going to be a little bit taller, a little bit wider, a little bit everything. So we'll say height plus 2, width plus 1, height plus 1, width plus 1, negative width plus 1. Or should be negative width minus 1. Let's try that. Negative width minus 1, height plus 1. So we have these center things of vertices that we're going to kind of draw the rest of the sword with. Good, good. So let's make a new face on the left side of the sword. So it'll start at the top right corner. Which I guess would be 4. Then go to the corner tip, which I think is... the last one? 7? And then back up to the bottom corner, which should be 3. So with any luck... Not quite. It's hard to see. Why is it all black? Three.js... thing is all black. Let's try changing the material from a Phong material to a basic material. Nice, that's good, but now we really can't see the 3D-ness of it. There's something wrong with the spotlight or the size of the sword. Weird. Does anything change if we remove the spotlight? No, nothing. It's the exact same. Do you have to move it back? Does the order that we add the thing to the scene matter? No, apparently not. Why does it work for our Triforce and not for this? Let's try doing a box geometry again. So now our box geometry is just looking totally black, so we can tell something's got to be wrong with our camera. Okay, so the spotlight, it can't be too close, it can't be too far, or we can just turn the intensity way, way up. Yes, good. All right, goodbye box geometry. Hello, regular geometry. So it still looks black, but let's take the intensity and turn it way, way up. No, it still doesn't work. What if we move it way, way farther? No, even with the intensity set to 1,000, it just doesn't work. Let's try a different light, like just some ambient light. Three.js ambient light. All right, let's try it like this. No more spotlight. Goodbye spotlight. Hello ambient light. Looks grayer, but it's not really very mesh fongy, is it? Let's try a hemisphere light. Seems to have little effect. I'll go to directional light. Yeah, light dot directional light. So this light doesn't care where it is or how far it is. It's just a magical light that affects everything. But yet it doesn't affect our Fong. Why? Doesn't work on the cube either. That's weird. Right, so it seems the light is coming directly from the top, which is why we're not seeing anything great there. So let's make the position. What do we do there to define it? So equally x. How? Set position? So the light points at its target. That's weird. Let's try that, whatever. I'll say directional light dot target dot position equals. How do you define a position? Do you have to use a vector? 3 dot vector 3. And so a little bit the same y, a bit above and a bit forward. A bit backward. To the side but not in front. No, still nothing. So what's wrong with our spotlight? Why was that not working? Our cube's all messed up now. Doesn't like having a 1000 intensity. You can sort of see it. It sort of draws it out, but it's not very clear. Right, its position is just kind of weird, so it's like behind the thing. Right, so this illuminates a cube nicely. Will it illuminate our sword? No, let's try changing the height of the sword so it's more like the cube. No, it doesn't look like it. So we'll just make the camera farther away now. Let's also rotate the X. Is the spotlight above it for some reason? Is that why we're not seeing any detail at all? No, there doesn't seem to be any change no matter which direction it's facing. The light's just not interacting with it. Is it because we have to close the geometry? Will it not light open geometry like this? I don't think so, because it's not really, shouldn't really care about that. It doesn't matter where we put it, nothing changes. Three.js single face not lighting. Oh yeah, we have to compute the normals. Tricky, tricky 3. Well, we're gonna remember that next time. Do we even have it here, but it's blocked out? Oh, I love it. All right, look at it go. Now it's all shining up. We're finally seeing our sword. So once again, we forgot to compute normals. That's just so annoying. Don't you hate that? Let's move the camera out farther and get rid of the X rotation. So here's our sword, and now we can see the lights reflecting off of it so we can continue our drawing. So if we push this face, we can see it is not quite right. The first 2 points are right, but the third point is not right. Just try them all. Let's try picking a different set of sides. Let's do the top left 4 and the bottom left 3 and the one that is bottom left but behind, which number I don't know. 6. No, that's on the wrong side. 8. All right, cool. That looks right. So it's all looking good, and we want the computing of face normals always to be at the end, or our thing won't color right. Oh yeah, looking promising. Looking really, really promising. So let's finish this little ornamentation here. So I'll push another shape. And this is all tricky. So on the top right corner, and then 9. Not exactly. So start at top right corner. Do go back to that bottom corner with 8, but this number should be different. 7? No, not all. 9. Is there a 9? I don't think there's a 9. I don't think it goes that high. does. I guess that shouldn't be height plus 1. It should just be height. Yeah, look at that. Very nice looking part of the sword. So I can tell already the thickness is way too high. 0.5, make it a little less thick. And let's also define the fin width. We'll just make it 0.5. So instead of width plus 1, we'll say width plus fin width. Nice, that's looking pretty good. Let's move the camera closer and then change its position. Position z equals 10. Camera.position.y equals 10. Yes, bingo. So the height is way too short. It doesn't look like much of a great sword at all. Let's make it taller. Try the height of 15. Nice! That looks badass. All right, so let's try just getting the other 4 wings going on in these points, and then we'll see what we can do about just mirroring the sword face. So we only have to do it once, but we get this sort of double thick thing there, and then we'll just shove a cylinder on the bottom, call it a big old day. So we have all the vertices that we need. How should we do this? Let's put this code here. So first we define the inner part, then we define the rim, and now we start doing the faces. So the next face would be above it, and it would share 2 vertices. Geometry dot faces dot push new 3 dot face 3. So we know it wants to be 4 and then 5 and then 8. Ish. Not 5, 7. No, not quite 9. So we wanted to go from the top left corner to whatever this one is, its equivalent on the rim, which I guess is 9, and the top, which I guess is 5. 4, 9, and 5. Looks promising, but is it going to fill in right? It's hard to tell with just a half triangle. We'll have to define another one that goes from 4 to 0 to 5. Almost looks right, but kind of looks wrong. There's like some overlapping there. Let's get rid of this one. Right, the hilt tip is actually a little bit higher. Should be height plus fin width. Nice. That looks more like the Dragon Slayer. We're not going to worry about the geometry too much because that just all, it basically looks right to me. The normals, it's not loving the normals because maybe I'm defining these in the wrong order. Let's try 054. Just looks the same. How about 549? Whatever, that's good enough. So that's looking pretty good. So we got that going. Now let's make the other two fins. Or could we fix these first? This is kind of bothering me. Isn't it kind of bothering you? It's the normals on this first one that aren't right. Like if we get rid of this first one, this all looks right. It's just this face that doesn't work. 9, 4, and 5. Yeah, that looks right. All right, that's looking good. Now, should we just write the code again, or should we kind of just duplicate this code so that it is on the other side? I guess we're going to have to do it by hand. So we'll define a new face, and it'll go from the top right corner is 1 to the bottom right corner, 2 to the top upper lip, which is 7. Let's make it rotate the other way while working on this side. Yeah, it looks good, man. And now another from its top right corner to that same corner, but to its equivalent on the back, which is 6. Good, but the order's wrong. 1, 7, 6. Oh, that's slick. It's fudging slick, guys. Normal's wrong with one of these ones. I think there should be 4, 8, and 9 by my reckoning. Nice, that normal's looking a lot better. And then we'll also get this lip going here. Not exactly. So we want this to go from the top left corner, 1, to the tip, 5, and we want this to be something. 7? No, not 7. Something on the 1, and then the tip, and then an 8. No, 6. Bingo. Ish. Is that normal, right? Looks pretty right. We're going to need to get the other one in there going. So 6, 1, and 5. And then to the next one. Or to the very tip, 0, 1, and 5. Oh, cool. It's working. Now I just got to fix up these orders because that's not right. 1, 6, and 5. That's freaking perfect, you guys. God dang. That's a good looking sword. All right, so without further ado, let's define a bright and a dark material so that we can kind of get this bright material going here with its thing going and this dark material going here with its thing. So this existing material already looks pretty good dark, so we'll say base sword material. And I'll just call it that for now, and then we'll say const light sword material. equals sort of the same thing. Its color, I guess, should it be white? No, I just sort of off-white. 0 DDD and more reflective. And we'll make this one less reflective, kind of matter. And then also dark. Is there a dark gray? No, so without dark gray, it just makes it white. But we can pick something manually, like CCC, too bright, 333. That's looking good. So now we're actually going to make the whole sword, not base sword material, but light sword material. And now we got to make one sword the dark material. So we'll make an index of materials. So base sword and light sword. And that should be the same. We don't want light sword material. We want 3.face mesh material. And now none of these faces have any materials defined, so they're just crazy looking weird. So face mesh material has been removed. Use an array instead. Light sword material. Base sword material. Cool. But now we got to change the materials index. Geometry faces 0, material index equals 1. Good, so we got the one thing that's dark good, and that's actually the one that we want. I think we actually want 0, 1, and 2, these 3 central pieces. Anything that's not part of the lip. Yeah, guy, look at our sword go. I can just see Guts swinging it around now. Whoop, whoop. Oh, that's cool. All right, so that's a good looking sword. This light material is a little bit too light. Whoops, where did it all go? This light material is a little light. Let's darken it up. Not DDD at all, but maybe AAA. Nice. All right, so we're just gonna get these, we're gonna make this sword face function into a script, and then we're just gonna make another sword face and just flip it in a container. So it looks like a whole sword, but it's not really. How are we gonna do that? So let's put all this functionality that makes this sword, and we'll make it into a function. Function get sword side geometry. And it will just do all of this stuff, but then it'll just return the geometry. And we'll say const face 1 geo equals get sword side geometry. I'll just call that geometry for now. And we'll call this sword main 1 because there's going to be 2 sword mains. And now we'll add a container. How do we add a container in our other pen? Is that just a cube with 0, 0, 0? Yes. So we have our container, and we'll actually add the container to the scene. And we'll add the sword main 1 to the container. Good stuff. And now if we rotate the container, it should basically work the same. Or no, the container doesn't have a rotation. Container mesh. We don't add the container, we want to add the container mesh. It's all about that mesh, guys. Good, looking good. So let's move this container up to the top. Let's just call this geometry. Can we just use the exact same geometry twice? Let's try it. So then we'll say sword main 2, and we'll actually just use the exact same geometry and the exact same material. But we'll say sword main 2 dot rotation dot y equals 180. Ish, but it is rotated kind of wrong. Math dot pi, is that what we got to get at? Oh yeah! Look at it go! Oh, that sword's ready to kick some fudging butt, you guys. Oh yeah! All right, let's make this inner material a little darker. This outer material a little brighter. BBB, 222. Oh my god, that's so awesome. Look at that freaking sword. All right, wow, well, what next? So this is good. We're going to do the hilt. We're going to do a little semicircle ornamentation last. I don't really know how to do that. But for now, we're just going to do the hilt. And the hilt's basically a cylinder with a little ball in the end. I'm sure if we do a cylinder and a ball, we'll all be set. So we got these sword side geometries. Now we want to create a cylinder to be the handle. Let's say const handle geometry equals new 3 dot cylinder geometry 11511. I actually don't know what these last two numbers do, but maybe it'll work. And then we'll make a mesh. Const handle mesh equals new 3 dot mesh geometry, and we'll make a handle material. And the handle material would be just like our other materials, but not reflective at all, in gray. And I know I guess we could just use a normal material for this, but let's leave it like that for now. Put a number 888. Handle material. Three.mesh with a proper punctuation. And so we'll add the handle. And then we gotta change the position all the way to the bottom. Position.y equals height. That ain't right. That ain't right at all. Right, because this is still using the sword geometry. You want the handle geometry for that. And we want to move it way, way down. 20. Let's just not draw the sword for a sec while I work on this. 20 is too low. 10. 1. What is wrong with our cylinder geometry? How about this reflectivity? Let's make this 0.1. What if we make this a box geometry? We see it now. Good. And it is definitely a little bit too low on the screen. Can I make this whole canvas bigger? Put a size of 1,000. 1,200. Seems to work. So we don't want a box geometry. We want a cylinder geometry. All right, let's look it up. Radius top, radius bottom, height, radius segments, height segments. Cool. So, 3 dot cylinder geometry, and we want it to be thin and tall. And we want it to have lots of segments, so let's say 12 and 12. It's nice and round looking. That's good. Now, why is it over there in the corner? What happens when we add our sword? Is it going to be in the right spot? Yeah, it basically is. How are we going to do this? We're just going to move the camera farther, I guess. Way farther. It's like with size, the camera has to be farther. Position Y, 20. That works for me. So we can see that our handle is way, way, way too thick. So let's define a const. Handle radius equals 0.2. Handle radius. Handle radius. The height looks just about right. So now let's change the position so that it's the bottom of the sword. Not too bad. Kind of looks like a popsicle now. 9. Where'd it go? Is it just off? No, 0. -1. Looks good. Let's make it a bit thicker because it's too thin. No one could hold that. Ah, 1 more decimal point. Looks fine. Let's add in the other side. Looks freaking slick, I can tell you that much. All right, let's add a sphere to the hilt. So we'll say const sphere geometry equals new 3 sphere geometry. I guess we just have to find a radius of 0.9 or 0.8. That should be fine. And const sphere mesh equals new 3.mesh sphere geometry and handle material. We'll add the sphere mesh. And that's looking good. And we'll make the sphere mesh position a little lower. -4. Looks good. It's a little bit big. Good enough for me. Is that handle all a little bit long? I think that's a little bit long. So we'll just move these each up by 0.5. Looks pretty phenomenal. Now all we need, I can't believe we've gotten this far. This is crazy. Good for us. Wow. So all we need to add now is these two semicircular sort of discs. So that might be hard. We might have to kind of abstract them because we can make cylinders, but how to make a half cylinder? I don't really know how we're going to do that. Let's look it up. Three.js semicircle. Nothing. Okay, so someone has made an example with extrude geometry, but it does not work. That's good. One that worked would be swell. Can we cheat a little? Three.js half circle. Could we make a cylinder and then mask it? Or could we just fake it with a prism and some skew? Three.js half cylinder. That would be good if we get that. The last two params of the constructor allow for a half cylinder? Get the fudge out. Get the fudge out, big old piece of code. Wow, that looks freaking awesome. Yeah, guy. All right, so let's try this crazy code we got. Var decoration geometry. We don't want it to be that big at all. We'll actually try and make it somewhat similar to our existing cylinder geometry. So 0, 1, 1, 5, 12, 12, and make that a const. Then we'll say const decoration mesh equals new 3.mesh decoration geometry, and I guess for now we will just make this handle material as well. Maybe we'll change it, maybe we won't. And then we will add the decorative mesh to the container mesh. And whoa, it's half a cylinder doing its thing. All right, let's not draw the rest of this while we get this right. So we gotta change the rotation. Decoration mesh dot rotation dot x equals math.pi divided by 2. Whoa, awesome. So that's halfway there, and then we also want to rotate it, I guess, around its z, the side that looks at us. No, around its y. Nice, looks good to me. Let's make it way thinner, just a bit thicker than the sword. Man, that's awesome. All right, what happens if we just draw it in? Is it in the right spot? Does it work? Yeah, it like basically is in the right spot. It basically does work already. Oh, that's awesome. Yeah, high five. So that is all looking good. Now we just need a second one of these. So let's just define another decoration geometry. Kind of hacky to just copy and paste it, but we're so close. Decoration geometry inner. So it's going to be a little bit smaller, but a little bit thicker. Thickness is important. 1.6. And then we'll make a decoration mesh inner. And we'll apply these same rotations to the inner one. I know, we could have written this better, and maybe one day we will. And then we just add the inner mesh. Yeah, that's awesome. That's a bit too thick, though. 1.4 should be more than enough. And that looks good. I wonder if we can add some color to it. Nah, that's good. Better to quit while we're ahead. Let's finally adjust this camera so it shows up nice and big right in the middle. Camera.position x equals 5, 10. Let's get it all the way over there. 15. And a bit higher. -5. And now let's zoom it on in by making the position closer. We want it to be a bit below the camera so it can't see that we didn't finish in that one last part. 2. And position X doesn't have to be so much. 12. Too much. Good. So that's it, everybody. We made Guts' Greatsword in Three.js. so huge, so huge. I think that's really really awesome. We got in this little filigree. We didn't get this under part, but that doesn't matter. No one's really going to look at that part of the sword. Can't see it in the picture. Here's the original sword in case you wanted to see them side by side. Looks pretty good. I guess it's not long enough, but hey, you can use the code to make it as long as you want. I encourage you to make the longest Dragon Slayer you can. So, thanks for watching. It's been grand. I am now late for breakfast, so that's gonna be bad, but a man's gotta eat. Thank you for watching. I hope you enjoyed making Guts' Greatsword, and please subscribe and also watch the rest of my videos. All the best!